At the very edge of our solar system lies a world that shouldn't exist. By all conventional logic, this planet should be a frozen, dead wasteland. It sits 30 times further from the sun than Earth. It receives 1,000th of the sunlight we do. It is so distant that high noon on its surface looks like twilight on ours. At these temperatures, the atmosphere should be frozen, solid, motionless, and silent. But it isn't. Instead, this world hosts the most violent weather in the entire solar system. It is a place of supersonic winds that break the sound barrier, storms the size of Earth that appear and vanish like ghosts, and an internal ocean where the pressure is so crushing it likely rains solid diamonds. It is the only planet in our solar system that is completely invisible to the naked eye. To the ancients, it didn't exist. To us, it is a blue enigma. This is the story of the final planet, the ice giant, Neptune. To understand why Neptune is so baffling, you have to look at the violence of its atmosphere. When the Voyager 2 spacecraft screamed past the planet in 1989, our only visit to this world, it didn't find a quiet frozen marble. It found a chaotic nightmare. Voyager clocked wind speeds at the equator, reaching a staggering 2,100 kilometers per hour. That is nearly supersonic. It is faster than the blast wave of a nuclear explosion. These winds are ripping through an atmosphere of hydrogen, helium, and methane at speeds that defy our models of physics. On Earth, our weather is driven by the sun. Heat energy from our star churns our atmosphere, but Neptune receives almost no solar energy. So where is the power coming from? How does a planet with no external heat source generate the strongest winds in the solar system? The answer lies deep below the clouds. Neptune isn't just reflecting the sun's light, it is glowing with its own power. It radiates more than twice as much energy as it receives from the sun. There is a furnace burning inside this ice giant, a remnant of primordial heat from the formation of the solar system, trapped for 4 billion years. It is this internal heat rising from the core and clashing with the absolute zero of deep space that turns Neptune's atmosphere into a global engine of destruction. This internal engine creates monsters. In 1989, we saw the Great Dark Spot. It was an anticyclonic storm roughly the size of the entire Earth. It looked deceptively like Jupiter's Great Red Spot, a permanent fixture of the solar system. But Neptune is far more volatile. When the Hubble Space Telescope looked for the storm just 5 years later, it was gone, vanished without a trace. Then new storms appeared in the northern hemisphere, only to fade away a few years later. Neptune's weather is transient and ghostly. Dark vortices open up like wounds in the atmosphere, rage for a few years, and then dissolve. We have even watched them drift strangely. Some storms drift toward the equator, a region where they should disintegrate, only to make a U-turn and head back toward the poles, as if they have a mind of their own. But the true strangeness of Neptune isn't in the clouds, it's what happens beneath them. If you were to descend through the violent blue haze, the pressure would mount exponentially. The temperature would skyrocket. You would pass through a mantle of superheated water, ammonia, and methane ices. At a certain depth, roughly 7,000 kilometers down, the conditions become hellish. The pressure reaches 7 million times that of Earth's atmosphere. The temperature hits thousands of degrees. In these crushing depths, scientists believe the carbon atoms in the methane are squeezed so tightly that they break free and crystallize. They form diamonds. This isn't science fiction. We are talking about a steady, relentless rain of diamonds falling through a liquid mantle like hailstones, slowly sinking toward the core. Over billions of years, these diamonds may have gathered around the planetary heart, forming a layer of solid diamond, potentially miles thick. This process generates heat. Friction from the falling diamonds could be one of the reasons Neptune is so warm on the inside, keeping the planetary engine running while its twin, Uranus, has gone cold and dormant. The irony of this chaotic, diamond-filled world is that for most of human history, we didn't even know it was there. Neptune is unique in the history of astronomy. It is the only planet found not by sight, but by mathematics. In the mid-19th century, astronomers had a problem. The planet Uranus was misbehaving. It wasn't moving the way Newton's laws of gravity said it should. It was wobbling, speeding up, and slowing down, as if something massive was tugging on it from the dark. A French mathematician named Urbain Le Verrier sat down with pen and paper. He didn't look at the sky, he looked at the numbers. He calculated that there must be an 8th planet and he pinpointed exactly where it should be. He sent his coordinates to an observatory in Berlin. On the very first night they looked, there it was, a tiny blue dot sitting less than 1 degree away from where Leverrier predicted. It was a triumph of the human mind. We discovered a world 4 billion kilometers away without even opening a window. But if Leverrier had looked a little closer, he would have seen something even stranger than the planet itself. He would have seen Triton. Triton is Neptune's largest moon, and it is arguably the most interesting object in the outer solar system. It is a rebel. Every other major moon in the solar system orbits its planet in the same direction the planet spins. Not Triton. Triton orbits in retrograde. It moves backwards against the rotation of Neptune. This single fact tells us a violent history. Triton was not born here. Triton is likely a cousin of Pluto, a massive dwarf planet that once ruled the Kuiper Belt. Billions of years ago, it strayed too close to Neptune. The giant planet's gravity grabbed it, snapping its orbit and trapping it forever. This capture would have been cataclysmic. It likely shattered Neptune's original moon system, sending debris flying to create the faint, dark rings we see today. But Triton isn't just a dead rock. It is geologically alive. Despite surface temperatures hovering near absolute zero, Voyager 2 saw geysers erupting from its surface, plumes of nitrogen gas blasting 8 kilometers into the sky. It has smooth volcanic plains, but instead of lava, it erupts water and ammonia. It is a world that is constantly resurfacing itself. And, like Europa and Enceladus, scientists believe that beneath its icy crust, Triton may hide a subsurface liquid ocean, a captured dwarf planet stealing heat from Neptune, harboring a dark hidden sea. And yet, despite the diamond rain, the supersonic winds, and the captured ocean moon, we have largely ignored Neptune. Since Voyager 2's brief flyby in 1989, we have never gone back. Every image you have ever seen, every close-up of Triton, every measurement of the magnetic field comes from a few hours of data collected over 30 years ago. We are trying to understand a complex, dynamic world using snapshots from the era of cassette tapes. Neptune holds the keys to understanding how solar systems form. We now know that ice giants like Neptune are the most common type of planet in the galaxy. Most stars have a Neptune. If we want to understand the universe, we must understand this planet. Neptune sits at the threshold. It marks the end of the planets and the beginning of the great dark void. It is a world of extremes. It is the windiest, the coldest, and yet surprisingly hot on the inside. It is a blue marble that hides a diamond heart. It is a gravitational bully that stole the king of the Kuiper Belt and forced it to walk backwards for eternity. It reminds us that the solar system is not a quiet, orderly, clockwork mechanism. It is dynamic, violent, and full of surprises that are still waiting in the dark. We have only scratched the surface of the final planet. The question isn't what we found there, but what is still waiting for us when we finally decide to go back. If you want to join us as we explore the deepest corners of the cosmos and uncover the mysteries of the universe, make sure to click that subscribe button and turn on notifications. We are building a library of the unknown, and you won't want to miss the next episode. Thanks for watching, and I'll see you in the next one.